Hello, and welcome to Modular Mining's CIIT presentation, discussing our latest technology offering, guided spotting. Your data has a story to tell. Are you listening? My name's Connor Williams, and I'm a sales engineer with Modular Mining. I'll also be joined by Braden Weisheit, our solutions manager, Loden Hall, for the Q&A portion. During this presentation, we'll discuss how listening to what the data is telling you can lead to a better understanding of mine loading practices and explore the functionality of our latest technology, the guided spotting system. So while we're actively broadcasting this presentation, we do want to remind everybody that all content contained within is the property of Modular Mining. So we took a three-step approach when we were deciding to address loading practices. Our company realized that mines have a wealth of technology at their disposal, and that they have this technology that can solve any number of mining challenges, from fleet management to machine guidance to asset health. But we noticed that it was fairly obvious that the loading process, specifically the interaction between the truck and the shovel, had minimal technology to support it. So with this in mind, the objective, methodology, and the ultimate technology that we produced were specifically designed to address the truck-shovel interaction. To illustrate the potential for production improvement, we need to look at an example mine, and we'll call this one Mine Alpha. So this shovel is running in a double-side loading configuration. Per site practices, a second truck starts to reverse into the spotting position before the loading of the first truck is complete. The second truck can't reverse into the spot until the shovel's bucket is hanging. This mine's pretty common in that regard. A lot of mines that don't have any kind of spotting technology do this as well. They hang their bucket and wait for the shovel to reverse into position. So what you might notice also is that this mine is really quite efficient. The truck holds short close to the shovel. Typically we won't see a pre-spot this close to the shovel. Usually it's many meters further away, kind of up towards the top of your screen there. The total time between the bucket hang and the time that the truck actually arrives at that point is about 10 seconds. Now keep in mind that in this scenario, the operator properly positioned the truck on the first try, did not require any kind of respot. So the time wasted when getting into position was quite low. In a double-side loading configuration, bucket spotting practices add, in the best of cases, tens of seconds to the cycle time. But they can add even more, as the truck rarely holds short as close as we're showing here. Loading practices are also subject to many other variables, from visibility due to environmental conditions, mine regulations, operator experience, bench dimensions, etc. All of these are taken into account when designing loading practices for a mine. These variables also increase the spot time. So spot time is important, though, because in a situation such as this, the spot time and the shovel hang time are directly linked. Spot time would not have a parasitic effect on shovel capacity if the bucket hang for reference was not required. That bucket hang time actually represents lost production time. So the removal of the bucket spotting practice can save time. It could bring a shovel hang time down from 26 seconds all the way down to 8 seconds. So what does this extra 18 seconds of capacity actually look like? For this, we'll need another mine. We'll call this one Mine Bravo. And for this example, we'll use that 18 seconds as the average bucket hang time, thereby showing the production differences that 18 seconds can yield. We're also going to assume 8 high-capacity hydraulic shovels producing at about 4,000 tons per hour and loading a truck every 5 minutes or so. So over the course of an hour, each shovel will load approximately 12 trucks. This results in a lost capacity of around 3.6 minutes per shovel. Over the course of a day, assuming typical idle time from breaks, shift changes, face cleanup, and the like, any individual shovel will load around 240 trucks. That equates to about 72 minutes of lost capacity. Over a year, that's 438 hours of lost capacity. And assuming that 4,000 tons per hour dig rate that we specified, this translates to approximately 1.75 million tons of available production per shovel per year. So if you extrapolate that across all 8 shovels across the mine, you'll start to see where I'm going. Over 14 million tons of available capacity are lost because of the bucket hanging practice. So in essence, 18 seconds of extra hang time from bucket spotting is costing Mine Bravo 14 million tons of production every year. So how can technology help? Well, the first step is to perform an assessment of the mine's loading practices. Over the years, mine operators have developed a significant and diverse technology portfolio. Using data gathered by fleet management and machine guidance systems, new insights can be gleaned into what's occurring at the shovel in real time and historically. A new process has been developed that meshes high-precision GNSS data from a mine's machine guidance system with distinct variables from the site's fleet management system. Correlation of time, position, and load status help us to determine if a shovel is double-side loading or single-side loading. And after that configuration is identified, the operation is able to define the percentage of time the shovels engage in double-side loading, define the percentage of time that shovels are over-trucked, establish a baseline spot time in the over-truck situation, establish a baseline spot time in the under-truck situation. And ultimately, the mine is now able to quantify the shovel's effective dig rate. Beyond this, though, the data can also show how individual equipment units and operators stack up against each other. And when presented with this data in an easy-to-digest format, such as a loading practice health card, the mine is able to outline performance against established goals and thresholds. So this is a loading health card, an example of one from Mine Bravo. You may be able to see something like this with this data. You'll be able to manufacture a card such as this. As we can see here, the 5 quantifiable shovel characteristics that we discussed on the previous slide have been assigned a health rating. In this case, when we're looking at the percentage of time over trucked, the mine's actually performing quite well. All shovels are at or above their 80% target baseline. So keep in mind that the shovel actually does need to be slightly over trucked if they're going to double-side load. This ensures that there's always a truck waiting to be loaded on the opposite side of the of the truck that's currently being loaded. Also look at the under-truck baseline spot time. The mine's also performing quite well here. This means that mine operators are not wasting time when they show up to an idle shovel. There are many reasons that a shovel may run out of trucks to load. This mine has done a good job of making sure that that situation is not being exacerbated by slow spot times or respotting events. Now, where the mine really struggles is in the percentage of time double-side loading and effective dig rate areas. As for percentage of time double-side loading, only one shovel group is meeting the 63% baseline for double-side loading. The established baseline depicts what the mine is capable of achieving. Every percentage point below that target represents an increase in the amount of time spent in a single-side loading configuration. And this directly correlates to lost time due to spotting and, furthermore, to increased hang time. So with a mine like this that's operating over-trucked, they have an ample supply of trucks to service the shovels. They should be taking advantage of double-side loading far more often. It is important to think about one specific hindrance that they may have. So one reason that the mine may be facing a decreased double-side loading volume is because of face design. If the face is too constrained for a second truck to spot on the opposite side of the shovel, then there's just no possibility of double-side loading. Beyond this, when we look at the effective dig rate, the shovels at this mine are also not hitting their 4,000 tons per hour goal. Now, the most likely cause of this is that the shovels are spending a large amount of time in a single-side loading configuration. And we know that this is significantly less efficient because as the truck is just getting kicked out, the one that's currently loading, it needs to clear the loading zone before the second truck can actually reverse into the spot. This increases loading times and hanging shovel events. Skill also plays a role. Inexperienced operators, or ones that are just not working efficiently, compromise the performance of the shovel. So data from the operator scorecards or other KPI-based measuring tools can highlight the performance of these individual operators and identify the need for training or the reinforcement of operational best practices to bring these operators up to standard. When we look at over-truck baseline spot time, we can see that the mine's pretty average. Some operators are at or below that 75-second baseline, but some take a lot longer to get into position. When they're above the baseline, the mine is wasting precious seconds of production and driving up the average time per load. So as we can see here, the mine's performing well in some areas. Their loading practices are struggling in other areas. They're struggling to achieve the goals in the areas that are actually the most important to loading efficiency. So this health card or other efficiency tracking tools such as this health card provide visibility to mine decision makers that allow them to acknowledge where they're performing well, while also identifying the need for improvement. The new visibility provides mine management personnel with the information they need to make effective changes to their loading practices. Effective changes may involve mine managers sitting down with the mine planners to redesign the load phase. They give the shovel more physical room to maneuver and increase the capacity for double-side loading. New visibility also plays a role in streamlining truck assignments. With this analysis method, we can now show you which shovels are double-side loading, and then we can show you which subset of those shovels are under-trucked. This allows the mine to divert assets from units with long queues and ensure that all shovels are being serviced at their optimum capacity. So focusing on the 5 main KPIs that we outlined earlier: percentage of time over trucked, under truck baseline spot time, percentage of time double-side loading, effective dig rate, and under truck baseline spot time, a mine can address the greatest hindrances to efficient and consistent double-side loading, thus increasing double-side loading utilization mine-wide. Now, for operators and operations looking to take their loading practices to the next level, this information will allow the quantification of the potential value being lost to suboptimal loading practices. That information can then be used to determine if acquiring the modular mining guided spotting system will yield the desired results. Furthermore, with this data in hand, a mine will even have everything that it needs to decide whether starting down the path to autonomy is the right move for them. Modular mining has solutions to all of these concerns, but today we're focusing on guided spotting. The guided spotting system is an optional module for modular mining's ProVision shovel system. It's installed either as an add-on to an existing instance of ProVision or as a standalone product. The solution uses dual antenna, high-precision GNSS with centimeter-level positional accuracy. One of the big questions that we get asked is why use GNSS? Why did we use GNSS instead of radar or cameras? And there's really 2 specific reasons. GNSS is near impervious to the environment. The system functions the same in snow, dust, fog, rain as it would on a clear day. The other reason is the compatibility with the modular mining product portfolio. Most of our products run on GNSS, and we're experts in the technology. As for the hardware consists of 2 LED displays mounted below the side view mirrors on the haul truck. When you look at this, you might be asking yourself, why are we releasing technology in 2021 that looks like a light board from the 80s? Why didn't we develop a high-res in-cab display? And the truth of the matter is we could have. We didn't because the operator would have a tendency to fixate on an intricate interface. The light boards feed 3 pieces of information to the operator in a format that is completely consumable in less than 1 second. Also, the displays are mounted outside of the truck, directly below the mirrors. This allows the operator to retain all situational awareness. The operator can focus on what's happening outside of the truck cab, remaining aware of hazards that may be present. The LED displays were intended always to enhance, not replace the mirrors or the operator's own instincts. But how does it work? As the truck nears the shovel, it crosses the loading zone. This is an invisible approach cone emanating from the spot location. The LEDs change as the truck reverses into position. The upper left corner of the light board shows the truck's heading as a red dot. There's a black line connected to that dot that shows the truck's approach angle to the center line of the approach cone. The numbers that you see below that box indicate distance in meters between the truck's position and the spot. Now, the bulk of the screen shows the truck's lateral position to the left or the right of the center line. And the colors change from red to green, to yellow to green, and the size of the rectangle shrinks as the truck approaches the center line. Now, once lined up on the center line, the display shows a green square at the top left corner with parallel vertical bars. This lets the operator know that it's time for them to straighten the wheel out and back straight in. On arrival at the spot, the entire display becomes solid green. This lets the operator know that they're in position and can apply the brakes and stop and wait to be loaded. So now that we've covered the hardware and a brief overview of how it works, let's check out a video that shows exactly how guided spotting functions. So before the truck arrives, the shovel operator will use the guided spotting user interface to set a recurring spot point in the optimal location for efficient loading. That spot is logged and stored on board the shovel until the operator changes it or the shovel moves. If the shovel does move, then the shovel operator just simply sets a new spot. So what we're going to see here is a truck operator that's a little bit overzealous. This truck's going to come through the loading zone and overshoot the optimum reverse point, actually ending up directly behind the shovel's counterweight. So what's important to keep in mind here is that you should notice that even with the truck out of position when it's starting the reverse, the system will still guide the operator to the correct spot without the assistance of the shovel bucket. As you can see, the truck is now in position and the shovel bucket is still on its way to the spot. Let's watch again. The truck enters from the right side of your screen and cuts across the loading zone. When it does so, this operator, once again, was a little bit overzealous and ends up behind the counterweight on the shovel. Now look at the right part of your screen and you can see the light board below the mirror. As the truck starts to reverse in, that screen goes from red to yellow to green. And once on center line and in the proper orientation, the screen displays the vertical bars. And then as soon as that truck reaches the position, the whole thing goes green. As you can see here, that truck was then able to stop and is in the perfect spot for that shovel to load it. So the use of guided spotting can provide benefits in 5 specific areas. First area relates to environmental concerns. Many mines operate in areas where visibility is frequently limited. Visibility is limited due to dust, fog, snow, heavy rain, and many other visual hazards. At most operations, once the mine is below the minimum visibility threshold, trucks are unable to spot. Trucks can't spot because the operators can't actually see the bucket. That makes the spotting impossible per site practices. So the threat of a truck shovel interaction in a case like this is actually increased. With guided spotting being GNSS based, the lack of visibility is no longer a limitation. With guided spotting installed, as long as the truck operator can see the LED boards, the correct navigation to that correct spot can be executed efficiently and safely. For mines subject to frequent visibility holds, this system could prevent countless hours of lost production and keep the loading cycle on track in all weather conditions. The guided spotting system stems from the adjustment of loading practices. Bucket hang to spot is no longer required, so seconds of hang time are saved on each load. Those seconds add up, and the guided spotting system brings the hang time to a bare minimum. Sometimes the shovel, though, does have to wait for a truck to get into position and can immediately transition, the shovel does not have to wait for trucks to get into position and can immediately transition from loading one truck to loading another truck without stopping to hang the bucket. Once the spot is set by the shovel operator, the trucks will continue to file in without any sort of input from the shovel. Now, assuming a constant supply of trucks, the shovel only needs to halt for face cleanup. Conventional concerns when designing a cut will also benefit from the guided spotting system. Without guidance, a large margin of error is required when designing a loading zone. This is because trucks tend to overshoot the zone and over travel. This creates a larger loading area footprint. With guided spotting, the visual cues reduce truck over travel. This allows site planners to create and design tighter benches without sacrificing their capacity for double-side loading. It is important to note that sometimes you just simply can't. You cannot double-side load all the time. This stems from the lack of available real estate. Sometimes there just isn't enough, regardless of what technology you have on the shovel. But a calculated reduction in loading area footprint can help to lessen spatial concerns across the mine. All mines, no matter who they are, face operator turnover and will eventually encounter inexperienced operators. These operators experience a steep learning curve in the operation of their equipment. This increases the risk of metal-on-metal collision events. With the guided spotting system, the disparity between a seasoned operator and a rookie operator is greatly reduced. The visual cues introduce a level of confidence and precision that these rookies didn't have before. These new operators then perform at a higher level than they would without the system. It is important now to note that the guided spotting system is not a purpose-built safety solution. The technology serves to increase situational awareness and help the operator maneuver the truck into position more efficiently. Therefore, if the operator is paying attention to the visual cues provided by the LED displays, the likelihood of a truck shovel collision in the loading area is significantly reduced. The guided spotting system also limits the negative impacts and inaccurate spots. When a truck gets too close to the face for loading, asymmetric loading may occur. While this is not immediately harmful, repeated occurrences create stress on the truck frame, leading to unplanned maintenance, unplanned downtime, and severe equipment damage. Guided spotting enables the shovel operator to set a spot at a reasonable distance away from the face. This therefore reduces the occurrences of asymmetric loading and protects the health of that truck over the course of its life. So, all of the factors that we've discussed contribute to a dual focus formula for success. By combining a modular mining loading practice assessment, complete with loading health scorecard, with Modular Mining's guided spotting solution, mines can then achieve a perfect spot. Thank you for joining this webinar, and at this point, we'll field questions from the audience. Thank you.